And I'm Tobias Schultz. I'm the Manager of Corporate Sustainability Services here at SCS Global Services. We are the program operator helping facilitate the development of this product category rule. And today I'm here to give an informational webinar that's about the public comment period for this product category rule for roundwood and pulp and paper. So before I dive into the meat of this, I'll talk a little bit about SCS and our role as program operator. I am on the working group that's helping to develop the PCR, but overall our role is to just facilitate the process, make sure that meetings go ahead as scheduled and holding webinars like this and just making sure the process moves along. And I'm just one member of a 8-person or a 10-person working group, I'm sorry. So this isn't just a SCS PCR, there's a wide group working on it. And SCS, we have been an environmental certification company for a little over 30 years, and during that time, for a bit over 20 years, we have worked doing life cycle assessments for a large number of different types of industries, including lumber, wood, and pulp and paper. So we bring to bear a lot of institutional experience into this, and we've developed one other product category rule as the program operator for steel products, and also helped review and served on working group of a number of other product category rules as well. And we're also committee members on the ISO and ANSI standards, and so we have quite a diverse body of experience in standards development that we're bringing into this initiative. But that's about SCS. This webinar is about this product category rule. So I'm going to dive into this for now and just talk about today's plan. So I'll first start by talking about the PCR working group members, just listing off who has helped to develop this. I'll talk some about the motivation for this PCR development, because as ISO standards require, there are other PCRs for wood and paper, and so it's important to justify why this one is being developed. I'll then talk about some of the PCR methodology key points. I won't talk about all the aspects of the PCR methodology because that would be impossible to do even in a webinar twice this long, but we will, after this webinar, send out the link. There's a public web page already on the SCS website, and we'll send out that link again so everybody can actually download the PCRs and look through the entire methodology points themselves. So again, today I'll just be summarizing some of the key methodology points. I'll also talk about the process for submitting public comments. And our intention here today is not to solicit comments. This is just an informational webinar to sort of talk through this process, who's involved, and some of the key points. It would just be unwieldy and impractical to try to collect public comments verbally in this place. So moving on now through this agenda, the list of PCR working group members. So as I said, I am Tobias Schultz from SCS Global Services. I'm acting as the chair and program operator, helping to facilitate and develop this PCR. And I'll just list off these other PCR working group members one by one. We have Ann Whalen from Appleton Coated Papers, Jeff Mendelson from New Leaf Papers, Henry Savignac from ChemPap Incorporated, James Ford, actually representing Climate for Ideas. There's a typo on this slide there. Laura Hickey from the National Wildlife Federation, Robert Vos from the University of Southern California, Richard Condit from the Smithsonian Tropical Research Institute, Susan Kinsella from Conservatory, and Yalmaz Siddiqui from Office Depot. So these folks have, since about August, helped to develop the PCR draft that has now been released for public comments. And a little bit about those steps in this PCR development process, what we've done so far and where we are now, and just a bit about where we will be going. So the current public comment draft, which is available on the SCS website, this was developed throughout the second half of 2015. And so this draft for public comment, as I said, is now available on our website. The public comment period ends on January 31st. After this point, all of the public comments that were received will be compiled and reviewed by the working group, and all comments will be responded to by the working group. not necessarily accepted, but they will be responded to, and then all of the comments and all of the responses will be posted publicly. And following that, there will be a peer review process that the PCR goes through after the public comment period, and a few other steps, but this is just a summary of sort of the public comment period and sort of key steps there. So how to submit public comments. This is just a snapshot from the SCS website where the PCR documents are available. And again, we can see a link at the bottom of the screen here, but I don't expect you to type that. If you don't have the link already, we will be sending out a notice to everybody who registered that includes the link as well. Now, how to submit public comments. It's a pretty simple process. You simply download the PCR documents. The very first page of these PCR documents is just an instruction for how to prepare and submit comments. And at the end of the day, you will send all of your comments to me, to Tobias Schultz. And again, if you just download those, it has all these instructions and more depth in there. So that's a very high-level background of the PCR process and where we are now in terms of public commenting. I now wanted to talk some about the motivation for this PCR development. You may know very well that there already are PCRs for wood, market pulp, and paper already which exist. So what is the basis for developing this new PCR? So this is sort of a little bit of the background before I go into the PCR methodology details itself. So life cycle assessment. I'm assuming most or all of us joining this webinar know what life cycle assessment is, but I'll just say 2 sentences to make sure everybody is aware. I mean, it's a study of the environmental impacts of a product system from cradle to grave, from extraction, processing, manufacturing, use, and end of life. It's often talked about as a great tool to measure environmental performance, and in fact, it is can be the only quantitative tool that can give a comprehensive assessment of environmental performance, but that's only if the LCA is done right. And if you look at the existing PCRs for wood and pulp paper, they have several methodology issues that the working group identified as needing a new PCR to resolve. So existing PCRs leave out about 2/3 of environmental impacts for one. They can use metrics which are not relevant, environmentally relevant, so they're inaccurate. There are some PCRs which use metrics which have very high levels of uncertainty. This is particularly metrics related to toxicity. So these can have uncertainty levels of as high as ±1 million%, and that's actually a statistic from a published literature. And often these PCRs can be very impractical, requiring excessive collection of irrelevant data that just doesn't speak to environmental performance at all. So just an example of an EPD based on an existing lumber PCR. This was verified by ULE, and it makes claims of including the product's full environmental impact and including all life cycle stages in the EPD and LCA, including forest management, logging, transportation, and the rest. However, it ignores some of the major impacts which can be associated with logging, which can be associated with things like clear cut and the erosion associated with that. And now this can be an issue because if you're hoping to use EPDs for, say, product comparisons or decision making, it'll really obscure differences in different sources of paper and from different forest sources, so different forest management practices for one, even in the same region, but also just obscures differences between wood sourced from different regions completely. So it's important to have an LCA framework that resolves these issues, and that's the basis and motivation for developing this PCR. So some of the key characteristics that the working group identified and discussed is including in just LCAs, PCRs, and EPDs generally for incorporation into this PCR. The methodology has to be complete, considering all of the relevant environmental impacts to the system being studied, the product being studied. The metrics must be accurate, so they must be quantitative and environmentally relevant and not have untenable levels of uncertainty. the PCR approach and must make the LCAs be practical. So there must be a streamlined, efficient implementation so that it isn't just excessive data collection involved in producing results. Standardized methodology for comparisons. Clearly this is important. That's the entire intention of developing a PCR, and also ensuring wide stakeholder support, because some of these issues, particularly related to forests, there's a large number of stakeholders that can be very concerned about these types of impacts, and making sure that all the relevant considerations are taken into account. So that's a little bit about a motivation, just as sort of a prelude, talking about the high-level key parts of this methodology. Perhaps one of the most important ones is the comprehensiveness of the impact categories considered. And this can be a big question, and it is a big question in many LCA methodology discussions on what specific impact categories should be included in an LCA and a PCR. And it turns out if you look at sort of impacts that should be considered to evaluate environmental performance just from a scientific basis, it becomes quite clear using a scientific analysis what impact categories are relevant. It even becomes possible for some of them to set a time frame on sort of measurement and required mitigation action. And this is important because it really is the driver of impact categories to be included, and in the end, the driver of the impact categories that are included in this PCR. So what are these impacts I'm talking about? Just for a few examples. So a few of these impacts that are threatening global sustainability. I mean, obviously everybody's talking about climate change. As you actually look at projections by the international and scientific community, this is a chart showing the global mean temperature from 1900 projected out to 2100. And in fact, the international community has identified 3 tipping points we'll be reaching in the next few decades. Today, the world is about 0.8 degrees Celsius warmer than in pre-industrial times, but these tipping points will be reached by beginning in 2035, when the world is projected to be 1.5 degrees Celsius warmer. This will be the hottest world in 10,000 years. After that point, when we reach the 2 degrees Celsius tipping point in 2050, and then finally the 4 degrees Celsius tipping point in 2100. But there's a clear urgent need for action in a short time frame, because if you look at some of the potential positive feedback loops, for example, methane from a thawing Arctic permafrost could send global warming spinning out of control. So clearly there's an urgent need for action on climate change in a short time frame. But there's other environmental issues that are absolutely relevant besides climate change. So for example, by within a similar time frame, by 2035, coral reefs around the world could be threatened from a number of different impacts, not just warming oceans, but also ocean acidification, which is a critical impact to include, but also others such as eutrophication, overfishing, and other impacts. And obviously, there's major threats to the world's tropical forests going on. This is an aerial image of a location in Borneo showing palm oil plantations in the middle of the rainforest. So clearly big threats on a large scale to many of the region's forests, and clearly a major issue for wood and paper from forests associated with logging. Human health impacts. This is a statistic from the World Health Organization. By 2035, there'll be over 4 million people dying early each year from inhalation of smog. This is actually a time-lapse photo from Beijing. This is just sort of not even necessarily a bad day in Beijing, showing smog levels, and there's all sorts of pollutants associated with that, including particulates and tropospheric ozone and other pollutants. And it's very important to consider all of these in the LCA. And indeed, if you just look at the scientific basis and of any meaningful consideration of environmental performance, it's critical to include all of these impacts. And that's the sort of motivation of this PCR's framework, developing a complete and accurate LCA framework tailored specifically for wood, pulp, and paper, to ensure that all of the relevant impacts are included in the consideration, that they're measured in a way which is accurate. I do want to talk a little bit about the background too, because actually there are draft ANSI standards and proposals at the ISO level for adoption at a very high level of an LCA framework that's complete and accurate, considering these impact categories and some of the key needs for LCA I've discussed. So just at a very high level, the protocols for complete, accurate, and practical LCA. There's an initiative to standardize this LCA framework in the U.S. through the American National Standards Institute, or ANSI process. This is the LEO 002 standard, which is currently in final draft form. There's also been a lot of discussion at the international standards level at the ISO Technical Committee 207, and in fact in the first half of 2015, a coalition on the U.S. negotiating delegation to ISO proposed revising ISO 1444 to include this LCA framework. So there's a number of stakeholders interested in including it at that level. And I'm going to talk a little bit more about this proposal because it serves as the genesis for the LCIA, the Life Cycle Impact Assessment methodology used in this PCR. And the specific submission by this coalition on the U.S. delegation was part of the N505 ballot. This number doesn't matter. This is just the ISO indexing system, and it's just sort of the where and when the specific methodology was proposed. So it was part of an inquiry on the potential revision of the ISO 1440 and 1444 standards. And both a ballot and a background document were submitted, which, amongst other things, included a complete set of impact categories in LCA. So there's actually a full list of all impact categories which should be considered, a framework for establishing metrics which are environmentally relevant and accurate, and also guidance for streamlining LCA using an iterative approach. So this is very important. I won't go into the depths of this background document. It's a bit over 20 pages long, but between that and the draft ANSI standard I mentioned, those are sort of the basis and genesis of the PCR methodology that has been we've been developed and is now going into public comment. So which are the specific impact categories included? I won't go into all. There's about 30 that this N505 ballot requires be considered generally in LCA. They fit into 5 different groups that consider a complete set of impacts relevant from anthropogenic activities. This includes the depletion of natural resources, impacts to terrestrial and freshwater ecosystems, impacts to ocean system ecosystems, impacts to global and regional climate systems, and finally, impacts to human health. The framework in this ballot, this N505 ballot, had a number of requirements for ensuring the metrics that are used are relevant and accurate, and this is really to ensure that the LCA can be used for meaningful comparison between products. So, for example, it would allow for the comparison and differentiation between logging associated with clear cuts that could lead to landslides and impacts such as this, or more low-intensity selective forestry that might not have as high impact levels. So the intention is of this effort at ISO and ANSI is to allow for LCA which can enable meaningful comparisons. There's wide stakeholder support for this LCA framework at the ANSI and ISO level, including representatives from governments, academia, environmental groups, industry stakeholders, and life cycle assessment experts. SCS is a member at the ISO level and of the ANSI committee, so we are participating on those, as are a couple of the other working group members. There's also a lot of support from the environmental community, and in fact there's a letter published during the international ISO meeting in September last year in New Delhi, advocating that ISO standards be upgraded to include this type of life cycle assessment framework. So there's wide stakeholder support for this LCA framework at the ANSI and ISO level, and also in this PCR. So that was at the very highest level a discussion of the background and motivation for the PCR, and sort of some of the background standards and motivations and discussions that have happened that have motivated this development and have also helped to contribute to the actual methodology development. So with that, I'm going to move from the background discussion and start actually talking about some of the key methodological points in the PCR itself. So scope and objective. So the objective is to develop product category rules for roundwood, pulp, and paper. And to do that, there were 3 modules developed, product category rule modules, one for Roundwood and actually one for market pulp and paper products. So there's 2 PCR modules separately defined for Roundwood and pulp and paper. Jointly together, they serve as a full PCR for pulp and paper products. And so these 2 documents set out the allowable scope and some of the boundary definitions without going into the details of the LCA methodology, which is dealt with in much more detail in the accompanying life cycle impact assessment methodology document. So when you go onto the SCS website to download the PCR documents, you'll find 3 separate documents there. These are these 3 module types of formats, and the intention here is to allow for flexibility of usage and just streamline the process of development and understanding. And as I said, these documents fulfill the requirements of this N505 ballot as well as this ANSI standard, but also the ISO standards, of course, ISO 1444 and ISO 1425. They're very much grounded in the existing ISO standards. These PCR documents also draw very heavily on a peer-reviewed life cycle assessment study comparing paper from 4 sources, which was published in October 2015. This is the most comprehensive LCA study based on these standards to date, and it serves as an excellent piece of the underlying LCA for this PCR. And having an underlying LCA such as that is actually a requirement of ISO 1425, so that's an important piece to include. So what's included in this specific scope in terms of the life cycle stages of this PCR? So this is just a really rough flow diagram showing the life cycle of paper products. And I'm sure if you're a paper expert on the webinar, you know that you can get into a much more detailed flow diagram. So this is just sort of a high-level summary, all the way from for virgin paper logging or waste paper collection with recycled paper through the pulping process and all the inputs that are required, energy, chemicals, and other inputs, the paper making process, and then the waste outputs that can be associated with those. Finally, after the paper is made, use, and then the 3 main modes of at end of life, which include landfill, recycling, incineration, and other disposal. So the specific scopes of each of these modules, the Roundwood module includes just this logging component, and so that seems like a small piece for one module document, but actually the complexities in doing a thorough life cycle assessment of some of the ecosystem impacts associated with logging were such that the working group felt that it was motivated to have a separate module. There's just enough complexity to warrant the separate documents. Whereas the pulp and paper module, this includes essentially all of the rest of the life cycle stages, all the way from paper making, allowing for printed products, and then allowing for scenarios on landfill, recycling, incineration, and other disposal. And the intention is that using the Roundwood and pulp and paper modules in conjunction, one can produce an EPD for a paper product, whether it's from virgin or recycled paper source. So these 2 modules jointly together allow for producing EPDs for either paper products. But the way this structuring of the modules allows for is also it's possible to produce EPDs simply for Roundwood products as well, even before the pulp and paper stage. So that's the very highest level, the life cycle stages. I'm going to get into some of the key methodological points of this PCR. One, talking about the allowed types of Roundwood EPDs. So for one, this can allow for product-specific EPDs. This would include Roundwood from a single owner operating in a single contiguous region. So this is really for a single company, say, or single operator at least looking to produce an EPD from a single region. But also industry-wide EPDs are allowed as well. So this is Roundwood produced in at least 3 distinct contiguous regions, possibly in multiple ownerships. And this type of delineation into product-specific and industry-wide is a practice in other types of PCRs. It's just something that we saw out there in the marketplace, and the working group felt was a good thing to replicate to allow for sort of greatest utility of this document, of these documents. The allowed types of pulp and paper EPDs. So for one, EPDs can be produced for market pulp or paper products. And so the product-specific level, this would include pulp or paper produced at a single mill, but also industry-wide can be produced as well. So this would be pulp or paper produced from at least 3 different mills. And there are separate requirements for disclosure and for these 2 different types of EPDs for both wood and paper. But these are some of the, those are the highest level categories that can be used. The functional units used in the PCR, this is obviously if you're a life cycle assessment practitioner, you know that this is one of the most important steps in the LCA is choosing a functional unit. And the functional units required in this PCR are selected at a scale to ensure that a system-level scale of impact is captured. Because if you look at something like examining the impacts of logging operation, it really isn't meaningful to try to assess ecosystem impacts at the level of just a few square meters at a time. Really, data collection must be at the level of thousands of acres to ensure there's anything that's accurate. So the functional unit is tailored to that level. So for the Roundwood PCR module, the functional unit is 10,000 cubic meters of roundwood. So just as sort of a rough average, this typically requires about 10,000 to 30,000 acres to be maintained in a logging regime per year. So gives a this functional unit of 10,000 cubic meters allows for this real kind of scale level of assessment, which ensures accuracy. For the pulp and paper PCR module, there's a functional unit of 10,000 metric tons allowed for pulp. So that's 10,000 metric tons of air-dried pulp, or 10,000 metric tons of finished paper. And that similarly is sort of scaled to a reasonable level of acreage that would be required for purely virgin paper of something like 8,000 to 45,000 acres to be harvested. So the basis of this life cycle impact assessment methodology, as I talked about in the motivation section, the list of impact categories that the PCR requires is derived from this N505 ballot document as well as this LEO ANSI standard. And of the 30 impact categories in these standards, 17 impact categories being relevant for wood and paper are identified. And it's important to focus on these relevant impact categories because some impacts are clearly just not going to be relevant to paper production. So something like overfishing is clearly a impact category that has nothing to do whatsoever with paper in any form. So for this reason, we're able to shorten this list down from the total relevant list of impacts, that list of 30, just down to this list of 17. Now, the results in the impact assessment methodology are calculated using 2 different characterization factors. So this is just an equation from the PCR that's the indicator result per functional unit. So again, if you're a life cycle assessment practitioner and you use different software tools, this is the type of calculation that the software tool automates. And the only sort of salient point to make here is that there's 2 characterization factors. The first is what's called the potency potential characterization factor, which represents simply an impact potential from a life cycle inventory result. And the second is the midpoint characterization factor, which just represents conditions of the environment, and both of these will vary by impact category. And these 2 characterization factors, these are based on this N505 ballot and ANSI standards, so this is sort of just taken straight out from those existing methodologies. And just as an example, characterizing energy resource depletion and what these 2 characterization factors are for this impact category, just using this concrete example. The potency potential characterization factor is simply the heat content of the fuel. So basically as simple as you can possibly get, you know, if it's a coal input, what's the gigajoules per ton versus the other types of energy resources, what's the gigajoules per barrel for oil or per cubic meter for natural gas, for example. The midpoint characterization factor, this characterizes essentially the scarcity of this energy reserve base. So this is the fraction of the reserve base remaining over the next 25 years. This is important to capture because you have resources such as coal, which there simply are, some estimates are decades or even perhaps centuries of coal reserves left even at current consumption rates versus oil, which is going to be perhaps just a few decades. So there can be big differences in sort of the realistic reserve base that's used, and why it's important to consider this in a characterization factor such as this. The specific impact categories in the life cycle impact assessment methodology, this is described in the PCR. So this is just an excerpt from the PCR of the table that's included. There's 2 slides here. It's longer than just this. So I'll just read off these impact categories. So first, in the group of biotic, abiotic resource depletion impacts, we have energy resource depletion, we have water resource depletion, and we have biotic resource depletion. Those are the general impact categories, and they have applicable indicators of non-renewable energy resource depletion, water resource depletion or water use depending on the data availability, and finally the timber resource depletion, which is relevant for virgin paper. Global and regional climate system impacts, so this is simply global climate impacts and global climate change. There is a allowance in the PCR if a pulp mill or a other life cycle stage is located in a region that is contributing to a regional climate hotspot, then it has to be included as a separate impact category. But generally, this is simply global climate change as one impact category. Ocean ecosystem impacts, the 3 impact categories that are relevant are ocean acidification, which is related to all CO2 emissions, ocean warming, which is linked to global climate change, but it's still nonetheless a distinct impact category. And finally, the impact category of persistent bioaccumulative and toxic chemical loading. The only relevant impact here can be mercury emissions that are associated with coal use, and coal can be burnt either at paper mills and or as part of the use of electricity grid. So that's captured in that impact category. Moving on to the second slide, showing this list of covered impacts. In the terrestrial and freshwater ecosystem impacts, there's quite a list. There's regional acidification, which treats acidifying emissions. There's freshwater ecotoxic exposure risks, and actually there can be 2 separate indicators here. So mercury, as I mentioned, and also for mills emitting dioxins, this can be relevant as well. And this is the case even in some mills in the U.S. that dioxin emissions can still be ongoing. Freshwater eutrophication, multiple indicators are possible if there's multiple freshwater bodies being eutrophied. And then finally, the PCR has a lot of detail on these impact categories of terrestrial biome disturbance, freshwater biome disturbance, wetland biome disturbance, and key species habitat disturbance as high-level impact categories. And for each of these impact categories, separate indicators will be recognized. So for the biome impact category, so for example, for terrestrial biome disturbance, separate indicators will be reflected for separate forest biomes that are impacted based on the WWF definition of terrestrial biomes around the world and the WWF Wildfinder database, which lists them. And for key species habitat disturbance, for example, separate indicators are recognized for each of the different species that are impacted in a region. And in fact, there's very specific details about the species that are to be listed. It includes only threatened categories. Human health impacts, this includes impact categories of ground level ozone exposures, ambient emission exposures, particulate matter PM2.5 exposure risks, and dermal exposure risks. So the first 3, ground level ozone, ambient emissions, and PM2.5 deal with air emissions that can be associated with paper mills or logging equipment or other life cycle stages. Whereas dermal exposure risk, this focuses very strictly on herbicide usage in certain types of logging. And this can be, for example, can be a major issue for even-age short rotation forestry. Often a lot of herbicides must be used directly after clear cuts. It can happen with selective forestry as well, and so that impact category recognizes the different herbicides that will be used in those cases and potentially exposing the workers that are applying it. So speaking to the practicality issue, there is what's called a default LCA approach, which can be allowed. So as you read through this public comment draft version, you'll see statements such as this and that can be used as a default. And the intention of sort of these default assumptions are that they represent the worst case results for a specific example, and representing the highest possible impact levels. And essentially, this are situations where the PCR simply has some data loaded into it representing a worst case that can be used in an EPD. However, the LCA and EPD developer can collect higher quality specific data to improve the level of data quality. And so the working group felt that to ensure that some of these impact categories could be calculated on a routine basis, it made sense to allow for these default assumptions that were sort of conservative in nature. And this allows for reporting in a practical way while still putting an onus on the actual LCA completer to collect higher quality specific data to ensure that the data is representative. So forest biome disturbance, there's a quite lengthy section in the life cycle impact assessment methodology document going into pieces as diverse as the sampling area that must be included, some of the sampling plot requirements, and here I'll talk some about the specific measurements which have to be collected in a forest to appropriately assess forest biome disturbance. And so this is critical because if you look at the wide diversity of different types of forests around the world and the different types of logging practices can be conducted therein, it really is just necessary to have site-specific data to do any type of meaningful assessment of forest biome disturbance. And there's five categories of measurements which have to be collected, synthesized, and integrated to assess forest biome disturbance. So we have the forest compositional structure, the forest size structure, relative measurements of biomass in different parts of the forest, the spatial forest structure which speaks to fragmentation, and finally surveys of the vertebrate species community. So for these first three, forest compositional structure, forest size structure, and relative measurements of biomass, these are the types of data points that are easily collected with standard techniques and in fact are very often collected as part of a forest management plan. For example, in the U.S., these data points are actually available for all forests in the United States through the Forest Inventory and Analysis Program via a public database portal. So very widely available and practical to assess. Spatial forest structure, so this can be easily computed with measurements using satellite data. And so what does a measurement like this mean? It would be something such as standard ecological measurements like the in a specific area, the total length of forest edge to forest area ratio, or the total fraction of a forest that's within 50 meters of a forest edge. So ecologists have actually developed a set of very specific measurements that speak to this spatial forest structure, and there's more detail in the PCR. And there's data available to assess this actually on a global basis using the Global Forest Watch, which is based on Landsat data from NASA. So again, this is something that can be done on a routine basis using public data. And finally, this fifth category, so this is the surveys of the vertebrate species community. We have two ecology experts who have weighed in, Richard Conrad and Bob Vos, on the working group, and their feeling was really that the surveys of the vertebrate species community was perhaps the most crucial type of measurement to include because it speaks to a whole number of different quality components of the forest biome. This is the most difficult part to assess, but most important. And for that reason, there's a default assumption allowing essentially that there's a very large reduction in the number of vertebrate species which exist in a specific forest area. So this is an example of this default assumption, which is very conservative. However, forest operators which have data on these vertebrate species can provide specific data if it's not such a worst case. Now this assessment's all wrapped up into essentially an evaluation of the percent disturbance of a forested area from 0 to 100%. And there's some other characteristics of the biome disturbance which have to be reported as well. And this is a table straight from the PCR document, the table 3, that lists out the required reporting parameters for forest biome disturbance. And so this is an impact category of key concern to a large number of stakeholders, including the environmental groups that are represented on the working group. And so there's a high level of detail and transparency that's required to be reported. So for one, the actual specific forest biome type, which is disturbed, must be reported. And this is to be based on the WWF Wildfinder database. The current biome status must also be reported. So this is to be reported as either critical, endangered, vulnerable, relatively stable, or intact. And again, these are the classifications from this WWF Wildfinder database, which is available online. So for example, this would distinguish a forest used with sourcing pulp wood from perhaps somewhere in Indonesia, where deforestation of endangered tropical rainforest is a major issue, from a place, say, in the region of Minnesota in the U.S., where the forests are in a much more intact state, where they might actually be rated as even relatively stable in this WWF database. So the type of forest biome as well as its condition must be reported. The current disturbance level in the forest, so this must be rated from 0 to 100%, and with 0% represents a fully undisturbed state based on an undisturbed reference area, which I'll talk about in a couple of slides, and compared to just a full difference in full disturbance. The full land use, so this is just simply the 1,000 acres required to produce 1,000 cubic feet, so it's essentially a measurement of the site productivity on a specific site. And then also trends in the disturbance level must be reported. So what's the whether the forest is currently in a state where it's increasingly becoming more disturbed, whether it's in a stable state to the current disturbance level, on a recovering trajectory, or if it's unknown. And finally, a key measurement is just looking forward, how much could the forest recover in a no-harvest scenario, and how different is the harvest regime that's being implemented from that no-harvest scenario. And that allows for differentiation between a type of logging regime that ensures the forest is in a much different state than it would be in a no-harvest scenario. And this forward-looking type of metric allows for real decision-making and a good understanding of a forest that's perhaps highly disturbed, but a forest operator is doing his or her best to recover it, awarding credit for those situations and not simply penalizing an operator based on sort of current disturbance, which could be related to historic forest management practices. So these are all the parameters which have to be reported if there's data, but actually as a default, the two data points which must be reported are the first two, the forest biome disturbed and the current biome status, which are both easily and readily available as long as it's understood where the logging operation is located. These other measurements of current disturbance level, land use, trend, and the rest can be very difficult to assess, especially on an international basis, and so they're not required for reporting if data is not available. So this concept of an undisturbed reference area, this is the entire basis of these ecosystem impact measurements, is basically considering the current status of a forest in terms of its biome condition and existing species versus the undisturbed reference area. And there's a highly specific definition of this undisturbed reference area, and this is just an excerpt from the terms and definitions of the PCR that does describe it. And the PCR working group spent quite a bit of time developing this, so I'll just read this out loud. An undisturbed reference area is forest/other wooded land which shows natural forest dynamics such as natural tree composition, occurrence of dead wood, natural age structure, and natural regeneration processes, the area of which is large enough to maintain its natural characteristics, and where there has been minimal human intervention, or where the last significant human intervention was long enough ago to have allowed the natural species composition and processes to have become reestablished. The chosen reference area shall have an average stand age of at least 80 years, and has had no significant human intervention, i.e. logging, intensive hunting, non-timber extraction, agriculture, mining, or other activities for the same time period, similar climate or elevation and rainfall within a reasonable distance, and have a contiguous area of at least 1,000 hectares. If no suitable undisturbed reference area is available in the region, then conditions in the undisturbed reference can be specified by a panel of at least 3 independent experts in local ecology. So the working group had an entire committee that sat down and spent a long time hammering out some of the details of this definition. Now, how is the forest biome disturbance and these other ecosystem impact measurements conducted? There's actually requirements for the sort of spatial scale and types of plot assessment that's allowed. And so this is just an excerpt on how to define what are called forest analysis units in the Roundwood PCR module. And these forest analysis units, or FAUs as they're known, essentially specify, have requirements on the things like the minimum area that must be considered in an assessment and that sort of characteristic, such that an EPD generator can't cherry pick perhaps areas of their land that are in better condition than others. They must include large enough areas to be fully representative. So I'll read through some of these key characteristics here, and again, this is a major topic for the working group. Within each forest analysis unit, measurements of parameters such as ecological conditions, carbon storage levels, and forest standing stock must be completed. Measurements shall be completed based upon a sampling plan based on measurements in forest plots with transects between each, meeting the following requirements. Plots shall be placed randomly, at least 1 kilometer apart and no more than 20 kilometers apart. At least 10 plots must be included in a forest analysis unit. No more than 50 plots shall be included in a forest analysis unit. The forest analysis units must cover areas which supply at least 20% of the pulpwood to the pulp mill. If data on the specific fiber sources to the mill are not available, then the forest analysis units included must account for at least 20% of pulpwood production in forests within 150 miles of the mill. And the forest analysis units shall be representative of the logging practices and forest conditions present in the entire fiber basket. So you can see there's quite a lot of detail on how these plot level measurements have to be conducted in the area that has to be included to assess these ecosystem impacts. There's also more detailed peer review requirements beyond what's in the existing ISO standards for LCA critical review and EPD verification. So there's specific elements which have to be a subject of the independent review, and there's requirements about, or recommendations about, a balanced stakeholder group and where the critical review findings must be stated. So this is the end of my slides for today. I hope this helped highlight at least some of the key points in this PCR. And again, this is just an informational webinar. We're not planning to solicit any comments or questions at this time. However, we will send out an email that has a contact information for myself and a link to the SCS website, so you can feel free to actually download the PCRs for yourself or reach out to me directly with your comments. And everything I presented so far, this is from the public comment draft, and we're ready and willing and excited to receive constructive comments to ensure that the methodology is the most robust that is possible. So thanks very much for your time, and this is the end of this webinar, and I look forward to hearing from you.